Hi, just a very quick follow-up video to the Rigol DP832 bad design investigation video that I did some time back. If you haven't seen it, this won't make much sense, so I'll link it in down below, so check that out. And yes, I've, thanks to John South at Imona here in Sydney, they're the Australian representatives for Rigol, they have upgraded my the PCB to the new version to fix this exact thermal problem which I discovered in the DP832 power supply. And has it made a difference before and after? Let's do some very quick measurements to find out. Yes, I'm getting about 247 volts mains voltage here in the lab. There's no load connected at all. I've had this turned on for a couple of hours now. I'm actually monitoring the heatsink through the side of the case as we did in the previous video, and last time we'll get in, I think from memory, well over 90 degrees just through the side of the case like that. And now we're getting a much more reasonable 57.6 degrees Celsius, 50, let's round it up to say 58 degrees. So that is certainly much better. Now we're going to crack the thing open and check, see, look at the design differences and compare it with the old board. I've still got the old one, and this is the old crappy little heatsink, as you saw in the previous video, that got to over, well, 90 degrees with the case on and well over 110 or more with the case off with no airflow. Now, I think they may have actually increased the fan speed slightly, but I could be wrong about that because I can't just whack the old board back in and try it. It has to do with the firmware, which isn't on this board. This isn't the main control board for that. So I will just switch it off, and I'll up the gain here on my microphone, see if we can hear a difference. It does not go at full speed though, so that rumour has been put to bed. No, they haven't just firmware set the fan to flat out. It does actually slow down. So here we go. So there you go. Hopefully you heard that. You heard it initially speed up at power on and then slow down once it was actually on. So it does not operate at full speed. They haven't tried to fix the problem that way. They've increased the size of the heatsink. And of course the fan still does speed up under software control if we load down the channel. So I'll do that now. So how do you check if you've got a new unit with the modified upgraded heatsink? Well, I'm not aware of any serial number ranges after which the mod has happened. Not exactly aware of that, but all units currently sold should actually, through any reputable dealer, authorized dealer, should have the mod from certainly the time of this video. It's actually they actually have been on sale for a bit of time, but you can actually see confirm it directly through the right hand side upper vent grill here right at the back. If you can have a look through there, and if you can see that large, you can see it down there, large silver heatsink like that, that goes all the way down like that. It should be a silver heatsink, well, silver aluminium heatsink, of course, just bare aluminium, not black anodized. If it is small or black anodized, it means it is one of the two previous versions of the board. And of course, here is my original board, the first version, as I showed. That is really bad, really horrid. But there is another version of the board in between this one and the new one I've got inside here, which has a rearranged heatsink. The capacitors are moved over to heatsinks over here, and it is a smaller, well, it is a larger black anodized, but not nearly as large as the unanodized one that we're going to see inside here. And I've taken the case off, and you can see the large heatsink right down in there. So, it is pretty easy to tell you've got the right unit through the vent holes. And here's my unit open with the upgraded heatsink. As you can see, much larger heatsink than the little tiny pissant one that we had on here. It's not black anodized, not a huge deal really. It is a thin tab LM317, one of those thin ones, but once again, that's not a huge deal. And yeah, it is pretty darn large. It's as large, it's about the same height as the largest heatsink on here. I won't bother really getting good angles on that, but there you go. It is just as big. You know, and it brings it down to an adequate temperature. They now don't have the caps right next to it, at least. So you know, it's not too bad at all. The airflow, of course, comes through the vents at the side like this and is sucked out the back like this. So, you know, there is some airflow over that heatsink. So what I'm going to do is do the same thing as last time. I'll power this thing on and I'll measure the temperature outside of the case, just for the reason that we can do it and to verify that it doesn't get too hot with no airflow. But of course, unless the fan fails in your unit, no airflow is, you know, not part of the real, you know, operational aspect of this unit. We're just doing this for kicks. And the version of this board is 2.10, the 26th of March 2013. So that was actually done before my design investigation, this change, but I definitely know, as I said, they have upgraded this heatsink to a different size one. They just haven't changed the layout since then. And my old board is, there it is, version 2.00, the 14th of January 2013. Now, as far as the differences between these two boards, well, I can't see any difference at all apart from the culprit LM317 5-volt supply around here, which they've obviously changed. So they have made two upgrades to this board. The first was to, you know, they realized this was too small. Oops, they rearranged it, moved the capacitors back, added the footprint for the larger heatsink over here. Is that getting hot? Ooh. Oh yeah, I can feel that. Ooh, ooh, touchy, burny, burny. But then they originally had a smaller heatsink than this anodized. They had a smaller black anodized one. Now they've gone for a larger one, which I think matched the same footprint, so they didn't have to upgrade the board. But apart from that, I can't see any changes anywhere else on this board at all, really, unless I'm missing it. But, you know, I'll post some photos up, but really, I think that's the only thing they've changed. And if I get down there right on the tab, that little thin pissant tab they've got on that LM317, yeah, I'm getting over 70. I could sort of leave it there for a bit longer, but certainly, you know, well within the operational limit of that case anyway, and in turn the junction itself inside the LM317. So not a problem at all, even outside of the case. But as I said, this is not the real temperature, because the real temperature, you would have some airflow over this thing. At the moment, we don't. This is just free air. And I've left that for a bit, probing the top of the inside channel there of the heatsink. Oh, been there so long, my fluke switched off. There we go. And we're getting over 81 degrees C. Once again, still with inside, you know, operational margins, even with this, even with no airflow. Much better than what it was before, of like well over 110. I think someone even reported like 120 or 130 or something ridiculous. It was off the charts. Certainly well over the max operational die temperature of an LM317. And no, they haven't upgraded the transformer or the transformer tap. It's certainly not part of the upgrade. Whether or not they'll do it in the future to get a slightly lower voltage into the LM317 after the full wave bridge rectification there, I don't know. I haven't heard anything, but presumably they won't change that tap at all. So as you saw right at the start of the video, I am on the quite the high side, almost 250 volts here in the lab. Sometimes, you know, 248 common, certainly over 245 nominal most of the time. So unfortunately, yeah, we do get quite a high voltage into our LM317 there. Nothing's changed in that regard. So that's basically problem resolved here. I mean, no issue whatsoever. If you've got an older unit, affected unit, Rigol will replace the board free of charge for you through your local dealer. Not a problem at all. Just contact your local dealer and I'm sure they'll do that, no issues whatsoever. And I'm, you know, pretty much worst case here, the 240 or 250 volt scenario, things like that. And yeah, it doesn't seem to be an issue anymore. I still would have preferred like a lower voltage tap. I still think, you know, there's too much voltage coming into the LM317 there, but you know, it doesn't matter. It's going to work just fine now. Very happy with it. And as I said, I don't know if that fan is a tinge louder than last time. Maybe it's just my imagination. I don't know whether or not it's just like a 2-speed fan, or whether or not they have actually upped the airflow just a bit as well. Not entirely sure. Anyway, there was one other issue, or two other issues actually. The first one was a software issue, and they have fixed that one. It's where on channel 1 only here, if you set your current limit to 10 milliamps down here, anything below 10 milliamps, so if we go across, anything below, you know, let's zoom in so you can see that. I've got, here we go, anything below 10 milliamps, it would show like 40 milliamps on there or something if you drop below that 10 milliamp current limit, even though you had no load on there at all. That was fixed quite some time ago, and not a problem. And here's something I haven't noticed before. It's not, I don't know, it's not really an issue, I guess, but it just shows the topology that they've got inside this thing. Let's say set this right down to, let's say 5 milliamps current limit. Let's switch off channel 1 here, okay, and then switch it back on and watch the voltage ramp up. I've got it set to 30 volts, okay, so pretty much maximum. And you'll see it won't instantly jump to 30 volts. It ramps up. It takes time to charge up. That's charging the output capacitor on the near the terminal front panel terminals down here. And if we, you know, even set that much lower, like down to 1 milliamp, there, let's do that again. You'll see it'll ramp up even slower in proportion to the capacitor. You could even work out the capacitance based on the time and the current there, I'm sure. So look at that, it just takes some time to ramp up. So that's the output topology used in this thing. And you can see that that is actually real with the meter on the output there. And if I up that, I can just up the current there, I can make it go real quick. And of course, if you set it to, you know, 50 milliamps or something like that, it's pretty much going to instantly sort of ramp up to your 30 volts there, especially at like 100 milliamps. Not a problem whatsoever. So that's an issue with some of the topologies used in these power supplies, the output configuration of the sense resistor to do the current sensing, and hence do the constant current, and having a large output capacitance. And as I've mentioned in like my power supply design videos and stuff, you want to, for a constant current power supply like this, you want to minimize your output capacitance for that charging up reason, and also for the reason that when your current limit kicks in, you don't want that capacitor, which can store a lot of charge in it, to actually dump out excess current over and above your set current limit to your load. Now, there was another big issue that somebody on the forum noticed. Because these channels here aren't floating, these two common terminals are actually, these two negative terminals are actually common. And you can see that they're shorted out internally here. The channel 1 is an isolated output, but channel 2 and channel 3 are share a common terminal. And if you hook up the load incorrectly on these, then it can cause an issue. I'll show you. Okay, we can easily demonstrate this. What I've got is channels 2 and 3 here. Channel 2 is just connected up to the voltmeter here, and where, as you can see, we're pretty much bang on there, almost to the last least significant digit. Channel 3 here, I'm just basically shorting it out through this current meter, so that we can just ensure that the current's exactly the same. And there it is, you know, 1 amp, 0.998, and everything's hunky-dory when you keep these, when you separate the channels like this. But as I just showed, these two common terminals are connected together internally inside here. So it shouldn't matter, theoretically, where we return this current, like the current coming out of this channel 3 positive terminal here, we should be able to return it to either this terminal or to that terminal. Aha! Let's try that. So what I'll do is I'll disconnect it, so now we've got no current flowing through here, and instead of having it come back to there, I'm going to have it come back to this terminal over here, and watch what happens. We still get our 1 amp, everything's just fine and dandy on that channel, but look what's happened on this channel here, 0.998. It's dropped by 20 odd millivolts there, and it's still, but probably more disturbingly is that it's still showing 10.005 here. So the actual output voltage, we're getting an error on. And for this, which is a precision power supply in the order, 0.05% basic accuracy, that kind of thing, this is a really big deal. So there's something going on there with the internal way that that ground comes back. These aren't just shorted together internally. And of course that error gets worse the higher current you go. I'm now at 3 amps there, and well, it's just, look at that, that's not good at all. But you may think, oh, well, what's the big deal? Don't you always return current back to the terminal? Well, no, not always. In terms of these supplies, you may just want to run to your product out here one common wire and the 2 voltages. You don't necessarily always run those 2 separate ground. So that's very common to do, no pun intended. And which terminal do you choose? Either way, you're going to screw it up because of the internal sense resistors there are in the negative lines. So as it turns out, Rigol have actually taken this issue on board, and they've thoroughly investigated, and they've written this whole document, which I'll link down below, which explains what's actually going on here and, well, how to avoid it. They haven't actually fixed the issue because it is essentially a design issue inside this power supply and a limitation of the topology they're using. And they show on this page here, this is the proper connection. As we saw, this is, say, channel 2 and this is channel 3 down here, and this red here shows the current path, comes out of the positive terminal back through ground and through the current shunt resistor down in there, and then that's our current error amplifier there, and that's all hunky-dory when you have those 2 separate paths. There's the yellow one, here's the positive terminal goes out, here's the negative terminal back here. But there's a common sense wire which comes back to, well, there's a sense wire from each terminal because they're doing 4-terminal measurement here. So there's a common sense wire coming back to a single ground point on the board here, and that is causing an issue which they show on this one, which is the improper connection, which we just demonstrated here. Channel 2, for example, when you run the current out through the positive terminal back down to there, it's fine. But on channel 3 here, when you run the current, instead of looping it back to its own ground terminal, if you put it to the other ground terminal here, then that current, as you can see on the yellow line, actually flows, that current flows through those sense wires, hence causing an error term there, which then is going to be different because they're tapping the voltage off at a different point. That's why the voltage, that's why the voltage doesn't actually change, the displayed voltage doesn't change, but the output voltage does actually drop. So that's a limitation of having these low side current sense resistors and this sense in terminal arrangement they've got in here. They just, it's just not suitable for this kind of thing. So Rigol actually don't have a fix for this. They're not going to fix the power supply, or at least, at the moment, they don't intend to fix this in the power supply. They're just telling you how to connect it properly, and when you're powering your product under test, use the correct return ground. And well, yeah, that's a solution. Another kind of a solution is to put a big grounding strap between the 2 like that, and that can minimize it. Doesn't get rid of it entirely, but can minimize it. We're 1 amp here, and as you can see there, it hasn't dropped by much. We're still within spec there. And if we go channel 3 and we increase that to 3 amps, for example, there we go. It's still dropping down a bit, but you'll probably find that's still well within spec. So that's a way to get around the issue. Just strap those 2 right at the front terminal like that. So there you go. I would have preferred that Rigol fix that thing, but hey, it's not an absolute showstopper. You just need to be aware of it as a user of this power supply, and I'll link in that document down below, and Rigol will probably update the manual in due course, pointing that out. I'm sure they'll get around to that. So yeah, I'm fairly happy with this upgrade. It did the job. It's fixed it. I'm going to put this back on my bench and use it as my main bench power supply. So it's not a bad supply now. They're starting to iron out all the problems, and Rigol did take it seriously and they fixed it. So if you've got one of these old units, go back to your dealer and they will fix it up and replace that board for you for free. And pretty much, you know, old stock is just going to get sold out. Make sure you buy from a reputable dealer, otherwise you may get stuck with an old stock unit, maybe. I don't know. It depends on when you watch this video and when you buy this thing, but this is a, you know, it's a half decent power supply now, especially for the money. I think it's, you know, pretty much a killer precision power supply. Just that trap for young players there with that common ground. Ugh. Catch you next time.